Hey everybody, and today I am going to show you how you can take something much more complicated that has a lot more moving pieces and organize it so that it's very, very pretty and deploy it with Docker Swarm. So this is the project that we're working on, deploy Celery Q Docker AWS. The AWS doesn't really matter here for that part. I'm deploying it on AWS. You can deploy it anywhere that a Docker Swarm is set up, which, if you remember from the previous videos, is anytime you have two computers and they can talk to each other, pretty much you can make a Docker Swarm with them. So what we have here is we have first our Docker compose.yaml, and I just want to show you that you can use the same exact setup. You can use it in like a development setup, which is normally what I do. So normally, I'll build all my images with Docker, and those will all be in Docker images, and then string those together into services. And I'll first test them out on like a single machine with Docker Compose, because I think it's really important to keep your process like really, really simple at first, because if you just try to immediately deploy to Swarm, you're gonna have no idea like if something's working, if something's not working, when things inevitably don't work, because they almost never work on the first try. Like you're not really gonna know exactly, okay, is it my service that's not working? Is it this one particular image that's not working? Like, what's not working? So to kind of avoid all that pain and turmoil, the very first thing that I like to do is set everything up in Docker Compose and just run it all locally, because that's just kind of the easiest thing to do. So what we have here is a Celery job queue. If you're not too familiar with Celery and job queues, it's not too important for the purposes of this lesson. If you are interested in getting like a deeper dive into how it works, go check out my free course on Apache Airflow, because the very first introduction to that includes quite a bit on Celery, and I also have a blog post somewhere. But for now, I'll just briefly mention it's a job queuing system, so it's very good for our purposes, because you have like something that creates the tasks, and then you have another something that executes the tasks, and then you have like a web interface that you can use to monitor these. So it's pretty cool. So what we have here is, again, we have our Docker Compose version 3, and we have our services. We're using RabbitMQ, which is just which is a provided image. RabbitMQ is a message queuing service that Celery likes to use for passing messages back and forth between like its worker processes and its parent processes. So you have all of this, and this is all good here. And then, oh, actually I didn't mean to have this here. Okay, so that's just ignore the fact that there's a deploy key here. If you have Docker Compose and it has a deploy key, Docker Compose, and you just do like Docker Compose up, it will just tell you like, oh, we're ignoring this key because it's not supported because you ran this with Docker Compose. So it's fine, you can have it there, like it's not going to break anything, but it's a bit cleaner to not have it there, I found. So then we have our job queue Flask app. So what this is I just wrote up like a really quick REST API that has a few different endpoints, and it has like a single task called add together, which is just takes as its parameters two numbers and then executes a Celery job that adds those two numbers together. Like, it's incredibly lame, but it's also very simple. And then you can, once again, you can see how you could build upon it and make it cooler. And we just have some environmental variables set here for convenience. This, once again, has a build context, because once again, this is something that I would develop locally. So this is not something you could do with Docker Swarm. You couldn't have an image that you were building locally. Whereas with Docker Compose you can, which makes it much nicer for development. And then I am using a load balancer. Sorry about that. I'm using a load balancer called Traefik, like traffic, like managing traffic, which is kind of a cool name. And what this does is, first of all, it does like a ton of cool things that I haven't even touched. It does like so many cool things. But mostly what I use it for is I use it to make pretty paths. Like if you've ever done proxy passes in Nginx, and if you're like me, you make typos and then you spend like hours and hours and hours trying to figure out like, oh my God, what's wrong? And then you realize that you forgot that / on the end, right? That's me, that's what I do. So this is what I really like about Traefik, is that you can do things like this. So for instance, let's take this service right here. This is the job queue Flask application. And what I'm saying here is that I want this, it will have a front end rule, and it has all kinds of stuff, but what it has is this front end rule, path prefix strip, /API, and the host is localhost. So this is really handy. So instead of having to remember all these ports like that I just never remember anyways, what I can do instead is just say, oh hey, localhost /API is where my API lives. It's also like much nicer for setting up services and things like that. You can have these nice names, and then you can do it without having to do the proxy passes in Nginx. I mean, like, I love Nginx. I still use it quite a bit, but I really, really like this way of doing things. And then it can also act as a load balancer, and I'm gonna get into that a little bit more later too. So you can see we have lots and lots of tags. For the most part, you can just you can pretty much just cut and paste this. One thing to pay attention to is this is the Docker network. So make sure if you're changing around your networks for any reason that this is updated. If you don't like even know what a network is, don't worry. I hate networking too. Just just keep the networks at the bottom of this file, which I'll show you in a minute, consistent. So that's it for this service. You can see we have depends on the rabbit image and the proxy. And then we also have our command here. So this is kind of one really nice thing about using Docker and about using Swarm and Compose. So you'll actually see in a minute that I reuse the same Docker image quite a few times, but depending on what I'm actually using it for, I'll have a different startup command. So for instance, this one, I say wait for it, which is this really handy script that I found. I know that I linked to it somewhere, so I'll make sure that it's linked to that the original person is linked to it, because this is a really great script. And what this does is it just waits for a host and a port, and then once that it comes up, it will execute a command, which is really, really handy. It's really nice to have that. Like if you have an application that depends upon a database or depends upon another service being up, this depends on gets you pretty far, but it won't actually wait until the services is started up. So this Docker depends on, this is for just actually making sure that the service has started, which doesn't actually mean that the stuff inside of the service has initialized. So this rabbit image could start up, but the rabbit MQ message queue might not have started yet, and then this takes care of that problem. This is like, okay, we're sure that this service has started here. Okay, and then this is Gunicorn, which is, Gunicorn, like unit or unicorn, I don't know, because it kind of looks like it should be unicorn, but I don't know. Whatever. Anyways, so this is the way that we are deploying our Flask application. This is a pretty standard way of doing it. Just make sure that you're keeping these ports consistent. So for instance, I'm just using the Flask default port, which is 5000. So I keep this as 5000. I have a log level, and then I have the actual application that I'm using. And then once again, you can see right here, this is the exact same Docker image. So we have all the same base stuff installed and used. It's just that we have a different startup command based on what's happening. So what this is the Celery Worker. This is just, it's just like a process that kind of runs in the background, and every time, and you can pass tasks to it. So what I'm doing here is I have this Flask application. The Flask application collects the data for the task that I want to execute, and then it hands it off to the Celery Worker. And so it's a bit of a separation of concerns as well. It's saying, like, listen, I don't care what's happening. I'm collecting the data, and then you're going to go execute it. And you're also going to go execute it someplace else. So it's going to stay out of the web application, which is a pretty nice way of doing things. But the really nice thing to note here is that we're using the exact same Docker image. It's just a different startup command. So this startup command is Celery, and then we're giving it the Python path, it's sort of like the Python import path, I guess, worker, and how many concurrent workers we can have. So this is also a nice way of getting multi-threading. And again, if you don't care about any of the Celery specifics, don't worry, I'm just going over them just a little bit just to give an idea of what this application does. And then job queue, Celery Flower. Flower is just a web interface that just shows us exactly what is happening, exactly what's happening in our Celery workers, how many different Celery workers we have. So that's where this concurrency comes in. what tasks we've executed, have any failed, have any succeeded, that kind of thing. And then you can actually see. And then this one, since this is a web interface, it actually looks very, very similar to what we saw before, except that I have path prefix strip is flower. Again, the host is localhost because I would be testing this out on my local computer. And then also this Traefik port changes. So I'm going to show you, so this port corresponds to the port of the service. So right here I have celery and flower, host, port. Okay, so you just want to make sure that whatever the port of the service that you're using also matches this Traefik port. And then once you have that, okay, then we also have the Traefik manager. Now the Traefik manager is, it's also a load balancer as well. So before we used HA proxy, which is high availability proxy. I like it for like smaller, like I'll use it for like smaller services, or if I'm trying to debug something, or if I just want to keep something really simple. But most of the time I use Traefik. There's a lot more that you can do with it. You can set up sticky sessions if you're using something like rshiny. There's a lot of nice stuff that you can do with it. So, so we have our command right here to start up Traefik with. And then I actually have a front end rule that will do this path prefix strip to Traefik. And yeah, once again, I left the deploy keys in there, but we're going to ignore those for right now. And then I guess I will mention the networks quickly. So when we're using Docker Compose, this is fine. When we're setting it up in swarm mode, there is going to be like one additional step with the networks. And you can just use the bridge if you're in Compose, but this actually it doesn't actually matter. Like this would be fine too, because I think this will now Docker Compose will set the network for you correctly. Okay, so we have that, and then I'm going to show you the Docker Swarm configuration. And the very first thing that we have up here is this Docker Network Create, and I'm going to show you that in a minute. This is what I'm talking about with with creating the different networks. So pretty much you're going to see it looks very, very similar, except that now we have these deploy keys and we have them where we should. And another thing is that we have an additional network called Web Gateway. And what that is an external network that allows Traefik to just talk a bit more. And that's about all that I want to know about networking. I don't like networking. I don't want to know about it. Okay, so then we have our deploy keys, and I'm going to say okay, I want one instance of this. I have my update configuration, my update policy, how many to update at a single time and what delay, the restart policy, the placement. I'm saying that I only want this on a worker. And once we have that, we have the job queue Flask application. Same idea, just add on this additional network. Same, the command is the same, everything is the same. One really important thing to note though, and this tripped me up really, really bad when I was first getting started with this, was that if you have labels and you're using Docker Swarm, you want to make sure that your labels are underneath the deploy key. Okay, so they're part of deploy. If you're using Docker Compose, I'm going to show you, they're up here, they're not under the deploy key. Okay, and you could have them in both places as well, but for the sake of not having this file be a million lines long, here we go. So then you can see that we have the Traefik front end entry points. So for me, because I'm using an unsecured server, this is just a dev server that I spun up, it's HTTP. If you have HTTPS, you obviously want to put that here. Again, I have this path prefix strip. This is something, actually, this is really handy. I don't think I talked about this. So you can have path prefix, okay, or you can have path prefix strip. And what path prefix strip does is it will actually strip this /API before it sends the request to your service, which is pretty neat because then you don't normally have to mess about with the actual prefix in your service. Sometimes you do, and I'm going to show you that in a minute. But for the most part, you don't, and you can just kind of treat it normally, which is handy. It's just like one less configuration thing that you have to do. And then you have to have the host. So one thing that's a bit annoying about this, you can't just specify this as localhost, which I tried to do, I've tried to do this a bunch of times. It doesn't work. You can't do it. If anybody has any insight into exactly like why that is, because it seems like, well, if I'm deploying this on a node, then it should know that that's the local host. But anyway, so you have to know the name of the host that you're deploying it to. It's right here. So if you have this set up as a load balancer and you have like an actual URL, that's fine. If you're just like me and you're spinning up some instances somewhere, or it's just a machine, there you go. It's this. It is your host name. Make sure it's without the HTTP or HTTPS and then, // So this is wrong. See this? Wrong. Very, very wrong. This will not work. And it will not give you any obvious errors over to why it doesn't work either. This is right. This is fine. So once again, all the same stuff. Again, so this is a little bit weird. The Docker network is still the Celery proxy, which is fine. Fine. I'll show you about that in a minute. Again, this is on the worker. This is on a worker swarm node. And then this one is our Celery Worker. And I think I actually have 2 instances because I say 2 workers. Yep. And then here is the network configurations. So we have web gateway, which is our external network that Traefik requires, and a proxy network. And again, our deploy keys, they always look pretty similar. So I'm actually just going to skip right over these because you see it's all the same stuff. Actually, wait, does this one? Okay, so I do actually just want to very briefly mention this path prefix. Most of the time, if you do the path prefix strip, especially if you're just doing something that's like just a REST API, that's going to be fine. But if you're launching a web service and that web service builds like a front end for you, oftentimes it needs to know the prefix so that it can build the front end for you. Otherwise, like you'll get really funny URLs. And most web services, they have something like this, URL prefix, some argument like that. Like just look for it, it's fine. It's not going to break anything, it's going to be fine. So, so there we go, path prefix, we have our host, we have the port, we're all good. And then we also have the traffic manager. Once again, we have our networks, we have our ports. If you are using an HTTPS, you can use 443, you can expose these ports because this is that, that's what you do for that. And, once again, we have all this stuff. I actually like to say, okay, have Traefik deploy its front-end interface because it also has a front-end interface on this path prefix /Traefik. And then this is the port, enable. These volumes with this Docker sock is very important. It's how Traefik manages to talk to other things. And then once again, we have deploy the labels. Oh, do I have I have this twice, which isn't necessary, but I have it twice. Okay, and then down here we have our networks. So we have our proxy network with the driver overlay. This is actually important. Swarm will only work, I think it only works with an overlay network. I know it doesn't work with a bridge network. And then this web gateway needs to be driver overlay and then external. And then this one is a little bit different because normally what happens is when you deploy your stack, Docker Swarm will automatically create your networks. But for whatever reason, when it's external, it won't, and you need to create it outside. So with that said, I mean, here we go. Here is, okay, so this would be the command to create the network. I have SSH'd into my Docker Swarm Manager node, and then this should just be Docker network create. I mean, it's going to tell me that it already exists, that's fine. And then once I deploy my stack, okay, so I deployed this earlier, so it's pretty fast. It's going to take you a few more minutes. Oh, just quickly, as usual, I just rsync all of my data or, my project directory right on over to my home EC2 user directory. Okay, and then I can do all my normal things. Docker service ls. And then I have some really fun things that I'm going to show you later. But for right now, let's just say, let's do this one, because this is the one, this is very similar to the one that we saw earlier. So what we want to do is we want to do Docker service inspect, and oh, that went a bit fast. Okay, Docker service inspect, and then the name of the service, which is what you get when you run Docker service ls. And then I like to do this -- pretty output just because I find it more readable. And then you can see we have like all kinds of fun stuff. It tells us, it gives us back our labels. It tells us what image we're using, tells us what host we're on, the worker constraints, the image, the command that we're running, any environmental variables. I mean, you get like a nice bit of output here. And then, since we have all that, what I'm going to do is I'm going to show you the Traefik interface, which is pretty nice. So, so I have this here. This is Traefik. What you can see here is that you can just see your path prefixes. These won't necessarily work as is. What you actually want to do is you want to use that the public DNS name, and then and then your whatever you set your URL prefix as. So in this case, this is flower. So this is the Celery interface that we defined in our service here. So let me just go back to that. Okay, so this is the job queue Celery flower. Inside of the service, it's running on 5555. And then I have it here, path prefix strip as flower. So that means it's going to come up like as my host name /flower, which is nice. Okay, so that's it. That's it for that. And then you can already see I had 2 concurrent Celery tasks working. So that's that. And then this is just a web interface about the Celery process. If you wanted to see okay, so what I did here was I just have a post call that goes to my Swarm Manager node, and then this is /API because that's what I have the Flask API running on. The task is add together, so that's what I created. And then I just send it some data that's just add these 2 numbers together. And then in response, I get back, I get the context and the request and the path, and then the fact that it was sent successfully 1. So that's it. That's how you take, like a really complex service, even multiple services that run off the same Docker container, and you make them nice and pretty, and you make them nice and organized, and you have lots of pretty path prefixes and all kinds of cool stuff. So that is it for this one, and I will see you guys in the next lesson where I tell you all about a really cool way of deploying and managing and looking at your logs and all that kind of stuff for all of your Docker Swarm instances. So I will see you in the next lesson.